dude, there's just too much to study. And for IGs, there's just so much, and I didn't listen in class to the student, and now like I can't cope with it. I can't cope with this syllabus.
Hey, don't worry. I heard there's an IGCSE Accelerator seminar coming out. I heard the teachers are very experienced.
Really? But would it help me though? Would it really help me?
Of course, this seminar is precisely for people like you. The teacher will run through the entire syllabus and highlight the important points that we should know. Hey, Mr. Win is teaching now. Should we go join the class?
Well, I'm gonna fail if I don't. Let's go.
Hello Kenjin, my name is Mr. Un. I've heard all your concerns and I believe that your concerns will be addressed at our IGCSE Accelerator seminar. So we will start with physics. We will look at this question. Now, this is about electromagnetic force. Now, don't confuse this with the electromagnetic induction. There is a difference. Force induced and EMF induced, they are totally different, but students always get confused here. Now, let's look at this question. There is a current carrying conductor in between two permanent magnets. So the question is, why the wire moves? So this is an example of an induced force. So when we understand that when force is being induced, we use the keyword overlap. Now, what are being overlapped? There are two things that are being overlapped. There are two magnetic fields that are being overlapped. Firstly, is the magnetic field of the current carrying conductor. This wire here. Now, when I draw it like that, it may look more familiar. So this is the magnetic field of the current carrying conductor. So just imagine the magnetic field being here. And so we have the magnetic field of the current carrying conductor. What is it overlapping with? It is overlapping with the magnetic field of, you've guessed it right, it is the magnetic field of the permanent magnet. So we have here two magnetic fields in the same region. So to answer this question, it is the magnetic field of the current carrying conductor overlaps with the magnetic field of the permanent magnet. So this is why the wire moves and this causes induced force. We'll move on to the next question. Now, very often students are confused with induced force and EMF induced. Look at this question. There is no power supply, and while rotating the coil produces an output voltage. Now this is very different from the previous scenario. The previous scenario is induced force. Now the keyword for induced force is, do you remember? It is overlap. But in this case, EMF is induced. Now for EMF being induced, the keyword that we use is cutting. Alright, so now what is being cut? Have a look over there. Yes, you see the permanent magnet there. North and south, and this is the magnetic field between the two permanent magnets. And do you see the coil here? Alright, so these two dots, I will illustrate them over here. And now if you rotate the coil, you can see that the magnetic field lines are being cut. Now whenever magnetic field lines are being cut by a full loop conductor, this gives rise to EMF and output voltage. So how do we answer this question? Well, remember the keyword is cut. Magnetic field lines is being cut. So we say that the magnetic field lines of the permanent magnet is being cut by the rotating coil, and this causes EMF induced. Now very often I see students answering this question using the word overlap, and very often the students use the word cut in the induced force question. Now this is totally different. Do not be confused.